right, let's take a little trip. We're heading to one of the most extreme, most mysterious places in the entire universe. Now, this is a one-way ticket, a journey into the ultimate unknown, because today, we're going to fall into a black hole.
So picture this. You're just floating in space, and then you feel it. A gentle but, really insistent pull. It's drawing you towards a patch of just pure, perfect darkness. As you get closer, the stars around you start to twist and stretch. It's like you're looking through a funhouse mirror. Even time itself starts to feel, well, weird. You are definitely on a one-way trip.
So what would that journey actually be like? I mean, what would you see as you fell past that point of no return? And what ultimately would happen to you? These are the big questions we're going to dive into. Okay, first things first. What is this thing we're falling into? Well, a black hole is what's left over when a giant star dies and collapses in on itself. To get a sense of the gravity here, imagine taking our entire sun and crushing it down into a ball just 3 kilometers wide. The gravity would be so insane that to get away, you'd have to go faster than the speed of light. And, well, nothing can do that. So nothing escapes. Not even light itself.
But hang on a second. If light can't escape, what are we seeing in these incredible pictures? That glowing, fiery ring? That's not the black hole. No way. That's called the accretion disk. It's all this stuff, gas, dust, whole stars even, that got too close. They get whipped into a frenzy, spiraling in so fast that friction heats them up to millions of degrees, causing them to glow like crazy right before they take that final plunge.
Now, to really wrap your head around what happens next, you gotta think like Einstein. His huge breakthrough was realizing that gravity isn't just a pull. Massive objects literally bend and warp the fabric of reality itself, what we call space-time. And a black hole? It's the most extreme warp you can imagine. It's like a bottomless pit punched into the fabric of the universe. And this, right here, is where things get completely mind-bending. Because of that insane space-time warp, there's not just one story of your trip. There are two, and they are totally different. There's the one you experience as you fall in, and the one your friend would see, watching you from a safe distance. So for you, falling in, it's actually pretty calm. You're in free fall, so you feel totally weightless. You look back out at the universe, and it seems like everything is playing on fast forward. But your friend watching you? Oh, they see something completely different. To them, you start to slow down. Your clock ticks slower and slower. The light from your spaceship gets stretched out so you look redder and then dimmer, until you just seem to freeze right there on the edge, fading away over what to them seems like forever.
And that is the absolute key. It's summed up perfectly by the physicist Brian Cox. From the point of view of someone outside, nothing goes into the black hole. Ever. To your friend, you are painted on the edge of that darkness for all eternity. They will never see you cross.
That edge, that boundary that you seem to be stuck on, that's called the event horizon. The best way to think about it is like a river made of space itself, flowing into the black hole. And at the event horizon, that river is flowing at the speed of light. So even if you are a beam of light, the fastest thing there is, you just can't swim fast enough against that current. It is the ultimate point of no return. But back to you, the traveler. You didn't feel a thing. There was no bump, no wall, no signpost. You just floated across this invisible line. But the moment you do, everything has changed. Now, every single direction you can possibly go, every path, leads to one single inevitable place, the center. And as you fall toward that center, you finally do start to feel something. And it's a process with maybe the best name in all of science, spaghettification. It happens because the gravity at your feet, which are a tiny bit closer to the center, is pulling way, way stronger than the gravity at your head. So you start to stretch. But here's a crazy twist. Your fate at this moment depends entirely on the size of the black hole you picked. If you fell into a small one, say a few times the mass of the sun, those stretching forces are so extreme you'd be torn apart, spaghettified before you even got to the event horizon. Game over. But, and this is wild, if you chose a supermassive black hole, like the one in the middle of our galaxy, its gravity is spread out over such a huge area that the stretching force at the edge is super gentle. You could sail right across the event horizon completely unharmed. You wouldn't feel a thing. So whether it happens before you get there or long after you've crossed, the end of the spaghettification process is the same. That stretching just keeps going. Your body gets pulled into a long, thin stream of atoms. Then even the atoms themselves are ripped apart. The fundamental particles inside them get separated. Everything that was once you is completely dismantled, and it all just keeps falling toward the center. And what's at the center? The singularity.
But here's the most mind-bending part of all. It's not a place. Inside the event horizon, space and time have swapped roles. The singularity is now a moment in your future. Trying to avoid it is like me trying to avoid next Tuesday. It's just going to happen. It's not a location. It's the end of time itself. So, okay, your physical journey is over. You've been deconstructed down to your basic particles, and you've hit the end of time. But is that really the end of the story? Because what about all the information that made you you? You know, the unique arrangement of your atoms, all your memories, everything you ever learned. Is all of that just gone?
This question leads to the biggest puzzle in modern physics, the black hole information paradox. It's a battle of the titans. On one side, you have Einstein's general relativity, which says whatever goes in, stays in, trapped forever. But on the other side, you have quantum mechanics, which has a law that's just as sacred. Information can never, ever be destroyed. So a black hole seems to break one of these fundamental laws. The question is, which one?
And the plot thickened thanks to the legendary Stephen Hawking. He figured out that because of some really weird quantum stuff right at the edge of a black hole, tiny particles are constantly popping into existence. And every once in a while, one falls in while its partner escapes, stealing a teensy tiny bit of energy from the black hole. This trickle of escaping energy is called Hawking radiation, and it means black holes aren't totally black. They glow, they lose mass, and over unimaginable amounts of time, they can evaporate completely.
And that creates a huge crisis. Because if the black hole can just vanish, what happened to all the information about you and the star that made the black hole and everything else it ever swallowed? If all that information is just deleted from the universe, then one of the bedrock laws of physics is flat out wrong. Now, this puzzle has stumped the smartest physicists on Earth for decades, but the current thinking is pointing to a solution that is just as wild as the problem. The idea is that the information isn't lost at all. Somehow, a perfect copy of everything that ever fell in gets intricately encoded onto that escaping Hawking radiation. It's like your entire story is imprinted on the surface of the black hole and then slowly, slowly radiated back out into the universe.
And this leaves us right here, on the very edge of what we know. Black holes, it turns out, aren't just cosmic vacuum cleaners. They're incredible laboratories. They push our theories of physics to the absolute breaking point. And they scream at us that there's a deeper truth we haven't figured out yet. The quest to solve this paradox might just be the thing that finally leads us to the holy grail of physics, a single, beautiful theory that explains everything.